Hi everyone, today we're going to go over lesson 3.7 and finish the chapter of chapter 3. So we're going to start with the definition of perpendicular. Perpendicular is just when two lines intersect to form a right angle. So in order to know that something is perpendicular, they either have to tell you or they have to put this little symbol that shows that they form a right angle. Now, if this is line A and this is line B, the way that we would write this out is we would use a different symbol, and it also means perpendicular, but this is how you would write it out in sentence form. Line A is perpendicular to line B. Again, without the little symbol here, we can't assume that it's a right angle, but if it's there, we know that perpendicular lines always form right angles. Now, when you're looking at this, technically there are four right angles. 1, 2, 3, 4. And I could, if I label this differently, we could name all of these angles. So if I label this A, this B, C, D, and E. So technically, I could label this and name four right angles. So let's do this real quick. So I have angle ABD, angle DBC, angle ABE, and angle EBC. Okay, just a quick review. Remember that the middle letter has to be the vertex, so that makes sense that they're all beat. Okay, now I did this for a reason, because theorem 7 says perpendicular lines form four right angles. So, because I know the definition, and I know it's perpendicular, therefore I know all of them are right angles. And that's everything that I just wrote out. That's my conclusion of knowing that they're perpendicular. Now, again, next chapter, we're really going to dig into these proofs and this will all kind of come together. But if I needed to justify why all of these were equal to each other, I mean, I know right angles are 90 degrees, but then I would have to justify that this information up here, that all of them are equal. So if I had to say ABD is actually equal in measure to DBC, which is equal in measure to ABE, which is equal in measure to EBC, I would be using the corollary to the definition of right angle. And this will make more sense next chapter. We're going to start doing some flow proofs, and we will use this a lot, actually. So, again, they need to be on your theorem sheet. We will actually, not the definition, but the theorem and corollaries are on your theorem sheet. And again, we will use this more later. Theorem 8. The angles in a linear pair are equal, then their sides are perpendicular. Okay, so this one we don't use quite as much as theorem 7, but let's talk about this. So, the definition of a linear pair. Definition of linear pair is when you have two adjacent angles that come together and equal 180 degrees. So they have to be adjacent, which means they share a side. And if they're equal, 180 divided by 2 is, 90. So if these two are equal, it would only make sense that they both have to be 90 degrees. So again, this one kind of is common sense. But if we're ever given a situation where you have a linear pair and the angles are equal, then, we know these two are the same, then we can say that they're perpendicular. And because they're perpendicular, we know it forms right angles. And because we know they form right angles, we know that all the right angles are equal to each other. Whew, that was a lot. Okay, moving on. So I have the definition of parallel. Okay, so something this definition doesn't say is two lines that do not intersect, and I need to add in here, in one plane. Okay, so let's say I tell you to draw two lines that are parallel. And so this is line AB, and we have line CD. A way that you can do this, there's two ways. First, if you're drawing the picture, if you put a little arrowhead like in the middle, that indicates that they're parallel to each other. Now, let's say you have other lines over here, and you want to also indicate that they're parallel. Well, you would put two little marks, and that would indicate those two are parallel, but they're not parallel to the other pair over here on the left. Now, if I were writing this out, I would say line AB, and then is parallel. This symbol means is parallel to line CD. So you really never have to write out the word is parallel to. You would just use the symbol of two slanted. It kind of looks like 11, but it's slanted. Okay. Now, we're going to do two proofs, and we're going to be finished with notes. You'll learn a lot of this stuff is I give you the basics, and then you have to do, higher order thinking and apply it to your homework. And that's why I get back on Teams every day at the end of class to take your questions, because I know it can be confusing. Okay, so let's start. I give you two things here, and I didn't mean to mark that through. And my proof statement is my goal. So I know that goes here. So, we can go ahead and put that here. And DTE are complementary. Now, just again, complementary means two angles come together and make 90 degrees. Now, remember, in this blank here, you never write the word prove. You're going to tell me, how'd you go from step 5 to step 6? And then you write your reasoning here. And we don't know that yet, so we're just going to have to wait. So let's go back to the top. Remember, this is a path. It's not just a separate step and a separate step. It's all a path, okay? So we're going to start with this given information. This looks a lot like a theorem that we have. And I know this is given, and it's right here. And, you can either mark it or something that we talked about it. Okay, we talked about that. Now, what does that tell us? Now, there's a major hint here, theorem 2. This looks like betweenus of rays. And if you look up theorem 2, this is the betweenus of rays theorem. So, let's look at our diagram. This means, remember how you read this. TD is in between ray TI and TE. Okay, so that's how you read it. Now remember, the part that you would write is that the little angle here, and that is ITD. And yes, you could write DTI, but T has to be in the middle. And the next little angle here, which is DTE, is equal to the total, which is angle ITE. Now, hint that you're going to write a given statement. We only have one left, so this is angle ITE is a right angle. Okay, so I talked about that. Let's check. Now, if it's a right angle, how do I know it's 90 degrees? I mean, some things you just can't assume. I know that you know that, but mathematically, what reasoning can I put that I know a right angle is 90 degrees? Well, that's going to be that I know the definition of a right angle, because if you didn't know the definition of a right angle, you wouldn't understand that right angles are 90 degrees. So, that's it. Major hint, substitution. We're going to substitute something. So remember, this is a path. We have to look back at all of our steps and see what we can substitute for the final goal of these two angles have to be complementary? Well, we know 90 degrees means they're complementary. So let me get my trusty highlighter out here. ITD, well, that's here. And DTE, that's there. This is our complementary. Well, what do you know about this? Don't we know that this means it's a right angle? Right? So, and since it's a right angle, what did we write down here in step 4? ITD is 90 degrees. So, can I take out ITE and replace it with 90? Of course I can. So, I'm going to write the angle ITD plus, and I'm looking at step 2, plus DTE equals 90. Again, I took this out and replaced it with the 90. All right, so I get a little highlighter happy. There, cleaned it up a little bit. All right, so now that I know it's 90 degrees, I'm now going to say, well, these two angles from step 5 are really complementary. How do I know that? What's the definition of complementary? That's when two angles have a sum of 90. So this again is another definition. Definition. If you want to use the word of, you can. I usually don't. I just say definition of complementary angles. Okay, so remember, when you do a proof, you can use any definition or property or theorem or postulate or corollary. So anything is up for grabs. You can use anything. Okay, so if you guys have any questions on this, please send me on Canvas or join me at the end of class, and I'll be happy to answer your questions. Okay, last one. And as you can see, last year they had a bunch of stuff due, and we're just doing one lesson at a time this year. All right, so when I wrote this, I couldn't find the perpendicular sign. So I'm going to rewrite this. Instead of saying is perpendicular to, we're going to use our new symbol, perpendicular to TN. And TA is perpendicular to AN. There we go. We're going to use shorthand. That's the way we normally would write it. Now, looking down through the proof, all right, let's kind of get our bearings here. We have two lines that are perpendicular, and I'm going to draw this on that diagram. AU is perpendicular to TN, so I know that's 90 degrees. And TA is perpendicular to AN, so that's 90 degrees. All right, so in the end, I'm supposed to prove that these angles are supplementary, so make sure you know what supplementary means. That is, two angles add up to give you 180. Now, remember, that's my goal. That goes to step 5. TUA and TAN, that's a weird angle sign, angle TAN are supplementary. Okay, now, I think the givens are only in one spot, so I'm going to put all my givens here in the first blank. Now remember, the information that they give you, you have to apply it to get your proof going. And I'm really giving you lots of hints on these. So let's say I didn't give you a hint. You would have to know what perpendicular means. Perpendicular means they form right angles. Now let's go back and look at some stuff in the beginning. How did we know the perpendicular lines formed right angles? It's going to be one of our new things from today. Okay, so from theorem 7, it says perpendicular lines form four right angles. So let's use theorem 7 for this situation. So perpendicular lines form right angles. So this is theorem 7. Okay, now how do I know right angles equal 90 degrees. Now, this is tricky because let's go back up and look, because you see the corollary that all right angles are equal. Is that what we're using? Let's go back and look. Is it the same situation? Are we saying this right angle is being equal to this right angle? No, that's not what we're saying. We're saying that this angle here and this angle both are 90 degrees. So how do we know right angles are 90 degrees? Because we know the definition of a right angle. So step 3 is definition of right angle. Okay, so now it says we're going to use the addition property. Again, we're going to have to use things from step 3, 2, and 1 to do that. And this is one of those weird ones. We're going to take and add these two together. TUA plus TAN. Now, if I add the left sides together, what do I get when I add the right sides together? I get 180. And I just did the addition property. Now, before you get confused, remember, don't overthink this. If I had TUA equals 90, and then I said TUA plus 5 equals 90 plus 5, you would have no problem saying that was the addition property because you added the same thing on the left and right. Now, instead of 5 equals 5, remember we're doing the same thing. We're adding, they're equal, just like 5 equals 5 is equal. We can just take the TAN and add it to the left and take the 90 and add it on this side. And so 90 and 90 is 180. So I know it's confusing. You will get the hang of it, I promise. Okay, so we need to justify this. How can I go from step 4 to step 5? What's different? I'm saying the same angles, but here it says 180, but in step 5 it says it's supplementary. So this is just a definition. Can you guess it? It's definition of supplementary angles. All right, so our test is in 2 class periods. We're going to have our review, and then we're going to have our test. And if you have any questions, please make sure you ask. Again, send me Canvas messages, join at the end of each class period for my Q&A session. All right, thanks a lot.